All right, so this is part 2 of our battery testing, and what I intend to do during this part is show you how to do a load test with a load tester, and then to show you how to do a parasitic drain. So first the load test. So I'm going to grab the camera here, and we'll look at our Snap-on AVR, which is an alternator voltage tester. And this is a digital one. The Sun VAT40 is an old analog one, which we still have, but this is the one we're going to look at today, which is the AVR. So just a couple things first. So to orient you to the tool, because this is what we need to do a load test. So these are what they call, these heavy, look like battery cables. They are what they call the internal 18-volt leads. And this is an inductive ammeter lead for getting amps. So it's going to read volts here. It's going to read amps here. And we're going to zero this guy here, and this is our load. So we're going to show you what we use that for. So in order to do a load test, what we have to do is to determine the cold cranking amperage of the battery. So you can see on this little sticker here that this thing produces 800 cold cranking amps at 32 degrees or 650 cold cranking amps at 0 degrees. So what we're going to do is we're going to take half the cold cranking amp output, and we're going to draw that out of the battery for a certain specified period of time and make sure that it doesn't drop below 9.6 volts. How is it that I just always get this? Oh. Okay, so I'm going to start the car. We'll see if this thing's a slow cranker. Okay, so it started up just fine. Cranking speed is good. So this tester giving me 200 amps at about 9.6 volts at about 15 seconds kind of makes me wonder if my AVR is really that accurate. Because I would expect it to have more amperage at 50% or only 200 amps. I kind of think, this thing cranks great. So I think what I'll do is I'll recharge the battery low and slow, and then retest it with the AVR and see what I get. All right. So unfortunately, this is kind of a weaker tester. But here's what we'll do. We got another tester. Let me pause here for a moment. So this is Snap-on DTAC Plus, and what this is this is a, I'm going to crouch down here. This is a battery charger, but it also will do a battery load test. So I'm going to show you how I'm going to do that. I'm going to see what this guy gives us. See how. So this one gets plugged into 110 volts, and I have a power strip on the back of my portable stand here. And it's got a switch on the back to turn it on back here. So I'll flip it on. And then on the front, I'm going to go ahead and put this back up here so you can see the screen. So it's a little hard to read, so let me bring it up close. So it has several things. It says main menu, and we're going to do individual tests. We're going to test the battery. We're going to do a battery test, and it's a conventional battery, and it's in vehicle. And then I'm going to put it up to inner battery size. I'm going to put 800 cold cranking amps there. And let me hook the leads up to the battery. So it's the same as the AVR. It's got the heavy internal 18-volt leads. And we're going to put red to positive, black to negative. And we'll hook it up and see what we get. Okay, it's hooked up. And I'll bring this up close so you can see it. So I'll hit, let me get it focused here, hit enter. And it's monitoring battery voltage. Let's see what it says. And it says vehicle interference, turn off all accessories and remove key from ignition before testing. Let me make sure that I did that. I think I did. I thought I put the key on the dash. Yeah, the key's up on the dash. So I don't know what the vehicle interference is, but the key is on the dash. So then we'll go in for return, and let's see if we can do an in-vehicle test. Let's see if it'll let us do it. It may not. Measuring battery impedance. Maybe it's letting us do it now. Okay, so it's doing it. So it's performing a load test right now. There's the battery voltage you can see. And so it's doing a load test for us right now. So we'll let it go here for a moment. And then once it's done, we'll come back and check it out. It looks like it's just about done. So let's see what we get here. It says select battery temperature. I'm going to say it's about 75 right now. That's as high as it goes, so we'll go there. So it says condition bad. Final voltage 12.4. It says available amps 587 cold cranking amps. So it says available is 587. We're supposed to have 800 available. So, but it certainly gave us more than the other one. So what's kind of interesting, if I had gone by the battery load test at the rated at 0 degrees, it was 650 amps. So this battery is testing a lot better than I thought. So it says the condition's bad because I told it had to be 800 amps. So let me look at the instructions and see if I can learn something more on this. Okay, so because I'm usually doing my load test with the AVR, not so much with the DTAC, went ahead and read the instructions. You don't have to input the 50% of the cold cranking amp. You just tell it the size and it tells you how much. So it says of the 800 available, it has, or rated, it only has 587 cold cranking amps available. They're saying it's bad because it's giving you only what, 60 or 70% of its rated output. It tells us that this is the internal impedance. They say it's at, 73%. Battery size, 800 cold cranking amps, just giving you some more specifics on it. So normally what happens is if it fails at a lower rate, and they didn't, in the instructions, it doesn't say how low, but if it really is, if it says, oh, you're really low, it'll actually automatically put the battery into a charge cycle. So what's interesting about this battery is the battery is relatively new, but the car sits around all the time. And I'm kind of surprised that it's actually reading as low as it is. Obviously, the car starts fine. So when they say the battery's bad, it's saying it's only giving us 73% of its rated output. We might be able to make the case that, and argue and say, well, maybe this battery is just oversized for the car. So 73% of 800 cold cranking amps, 587 is way more than it needs because the car starts and runs beautifully. So we're not going to throw the battery away or something like that. But the thing I don't like about this machine is, yeah, it's accurate, but it's just automatic. And you say, why don't you like that? Because from a teaching standpoint, you can't see the amperage going up and the voltage dropping as I'm increasing and giving it a load. Okay. Okay, we do have one other way of doing a load test. It's with this battery tester that this is what most dealers and shops are using now. This is not going to suck that current out of that battery anymore. What it's going to do is measure a battery capacity or impedance, basically taking a fancy resistance check on the state of the health of the plates and the electrolyte conducting electricity in the battery. So we just put the small lead to the negative, small black lead to the negative, and we get the other one to the positive, and I'll bring the camera over here so you can see what's going on the screen. And It says, is this an in-vehicle test? Yes. So I go, yes. Select battery voltage, and I'll say, yeah, it's a 12 volt. And it says the battery's good. It's reading 12.5 according to this thing. So then we're going to go to the menu. Sorry. Okay, so test battery. And we're going to say we're going to test the battery, and we're going to go to charging. We're going to go to the battery test there. Hit enter. There we go. And it asks us to select units. So, okay. It says replace battery where it's 60% is what it's saying. So this is basically telling us in a different way what the other tests were telling us. So that it's only giving us about 60%. But again, the battery's got plenty enough amperage output for what we need it to do for this car. All right, we're going to refresh our memory on the instructions now and redo this. So it says test battery. So we're going to go enter. And it says select units. So we're going to go to cold cranking amps, which is the it says which is the SAE ones. So we'll go, should be able to go to, there it is, cold cranking amp SAE is the one we're going to use. So we're going to say enter, and we're going to go to, scroll it down to 800 cold cranking amps there, and we're going to go enter, and it's testing it. And it says gave us 428 cold cranking amps, or 53%. And it says replace battery. Now, the DTAC was giving us 587, but we've done a couple of tests, so it's not really surprising that this is reading lower. This is not as accurate as the DTAC, but it's basically giving us the same kind of reading, that we're somewhere between 55 and 70%. And so that's another way of doing it. This one isn't so accurate, but it's accurate enough that most people are using it because we're not pulling a big load on the battery, and it's easy on the system. And so this is what most shops are doing. They just have one of these. And where a person like me says, when I see this, I go, the battery's only 50%, then I'm going to go, okay, well, wait a second. Cranking speed's great. It's working great. Why don't we just charge it and then retest it? So that's what I'll do. I'm going to charge it all night tonight, and then we'll retest this and see what it is after that. The other thing we can do is look at the date code on the battery. If we can see it, and on this one, it is not visible, but oh, it's there on the top, and it didn't get punched out, so we don't know what the date was. But let's assume it's a couple-year-old battery, and then it's cranking fine. We're going to go, hey, let's charge it and then retest and see what we think. Okay. All right, so here we go. We're done with battery load testing for now, and we're going to go on to what we call a parasitic drain, or short test. Basically, what this test says is we want to measure how much current is being drawn from this battery when everything's essentially off. We know that when we say everything's off, we got computers pulling memory, we got stereo preset memory, this thing has seat position memory, and we've got a clock, etc., those kinds of things. So for most cars, anywhere from 25 to 50 milliamps, or 0.025 amps to 0.050 amps is acceptable draw on a battery. So here's the scenario where we would want to do this test. You know, we come out in the morning and the car's cranking slow, doesn't want to start. We get a jumper pack, we jump the car. It runs and drives all day and runs fine, starts up, everything's great. Next morning it's dead again. So it looks like something is drawing power, too much draw on this battery. So we're going to measure that draw. Now, going into this test, we need to know a few things. First, there's a lot of computers on this car, and they will actually go to sleep. So for a few minutes, they'll draw a lot of current, and then slowly they'll go to sleep, they'll go to sleep, they'll go to sleep, they'll go to sleep. So it may take as much as 15 minutes. So what we're going to do is we're going to do the test, and then I'll pause and come back a few minutes later and show you what has changed, etc. A couple things. So in order to do the test, what we're going to do is, like you saw in the lecture, we're going to go ahead and disconnect the negative battery cable. And I'll do that right now. Take my 10mm wrench and put the rubber cover on the positive so I don't accidentally touch, and put my safety glasses on, being careful. And I got that clamp loose, and I'll wiggle waggle this thing. Hopefully I can get it off pretty easily. Here it comes. There, it's off. Now in order to do this test, I got to make sure that this negative cable doesn't touch the terminal. So I'm going to use the meter to measure amperage. And the way I'm going to do this, I'm going to take the red probe out here and put it over here where it says 20 amp up there. 20 amp. And this has a fuse. And so if I hook this up wrong, I blow the fuse in the meter. Not the end of the world, but we don't want to have to change it. So I'm going to put this all the way down on 20 amp, and it beeps at me. It's like, are you sure you want to be on amperage? Because it doesn't want me to now hook it up to the battery and blow the fuse. So for example, you can see this right now. You can see the meter down here. And if I were to accidentally put this red to positive, black to negative on the battery, I'd instantly blow that fuse. So what I'm going to do, let me grab the camera and bring it down in here so you can see, is I'm going to go ahead and put the camera right here. I'm going to go ahead and connect these leads, one to the terminal and one to the lead. So what that means is, if you think about it, if these are connected there and there, anything that comes out of the battery goes through the meter and then through the cable. But I don't want to risk accidentally blowing the meter. So look what I've got. I've got a little light bulb with two leads. And I'm going to touch the light bulb to the cable and to the terminal and see if it lights up. And yeah, it does light up. So there's a fair amount of current flowing, but it's kind of yellow. So I'm not worried about being too much, but I'm still not sure, and I don't want to pop the meter fuse. So I'm going to take an inline fuse connector with a 15 amp fuse. And I'm going to go ahead and connect it to here and to here, to the cable, and see if it, and there it's connected. And I'm going to see if it blows the fuse. I'm holding it there. Sure arced, but it's not blowing the fuse. So, and I look at the fuse and I can say, okay, it's definitely drawing current, but it didn't blow the fuse. So, although it did light up this, it was pretty dim, and it didn't blow the 15 amp fuse. So I'm confident that I can hook my meter up with this 20 amp fuse and not blow the meter fuse. So here I go. So I'm going to go ahead and put this here. Actually, let me hook this one, the negative, up first to the cable. And I'm going to go ahead and put this one here, and you're going to see me hook this up. But I want to show you the meter. So here we go. I'm going to hook it up. There you go. I just hooked it up, and it reads 2.13 amps. That's a lot of amperage. Now I'm going to set this down so you can watch the meter. Okay, so you can see the meter. Let me see if I can get this to a little bit better position. Yeah, that's a little better. So now it's reading, hopefully you can see that there's a decimal point there. It's 2.02. Let me roll this closer. Hey, it's starting to drop down. It's at 1.95. Okay, it's at 1.95, 1.0, 1.74, it's dropping. Now, obviously, I've got the keys out of the ignition, the dome lights are off, the door's closed. I don't have anything on. And we're going to look at the clock, and we're at 4:27 p.m., so it's in the afternoon here, actually, when I'm recording. Oh, it just dropped to 0.67. So inside of what, about a minute, it went from 2 amps all the way down to 0.67. But this is still 0.6 of an amp. That's 670 milliamps, and we said acceptable is 25 to 50 milliamps. So it's 4:28 right now. We're going to leave that there and see how long it takes for it to drop down to an acceptable level. So I'm going to pause the recording and then check it every few minutes and then see where we're at. So let me pause it. Okay, so literally the moment I paused it, it dropped down to 0.21 amps, and you can see the time is still 4:28. So it's only been about another minute. It's only been a couple of minutes, and we already dropped down from 2 amps to 0.21 or 0.20 amps. All right, let me pause it again. All right, I'm going to check back in for a moment to show you the time. We're at 4:31, so it's been about 3 or 4 more minutes, and we're still at 0.21 amps. I just want to let you know something. Let's say after 15 minutes, that thing's still at 0.2 of an amp. That's still way too much. That's still like 4 times over the accepted level. So then we come over here to the fuse box. We could start removing one fuse at a time, pull it out, put it in. Every time we pull a fuse out, we could check to see if our drain went away. Now the problem with that is we might wake up a module when we do that and all of a sudden it jumps back up. But if we thought we had a drain and all of a sudden we disconnected a fuse and it went to 0, well then we know what circuit that drain is in based on the fuse that protects it. Okay, so it's 4:32 right now. I'll pause again. We'll check back in a little bit. Okay, we'll check it out at 4:40 p.m. So we started all this at about 4:27. So about 13 minutes into it, look where we are, 0.01 amps. So this is 10 milliamps, and we said 25 to 50 is acceptable. So this is totally acceptable. So there is no parasitic drain that's anything unusual on this car. But if we had something like, a tenth of an amp, 100 milliamps, we know we'd have something draining down the battery. So if this customer came in and said, oh, my car keeps dying every morning, we'd say, you're leaving something on. Maybe you're leaving a power point plugged in to charge a cell phone. They're notorious for causing shorts. So if you're ever trying to diagnose a short, make sure all your power point charger devices are unplugged, because they are notorious. Okay, so we're going to disconnect this guy. And immediately I'm going to take the meter and put this back over into the volts ohms area and put this back to 0. So the meter's all shut off. So a parasitic drain test measures the amount of draw on the battery. I'm going to go ahead and hook this negative battery cable back up. And now it's charging everything back up. And I'm snugging up the negative lead. So it's measuring any draw on the battery. And again, if we had a draw, we could start removing one fuse at a time and see when it drops to 0, and then we would know which circuit it's in. Then we go to the wiring diagrams, find that fuse, see what it feeds, and start checking. Couple of rules of thumb. Power point chargers are #1 cause of drains these days. Door jamb switches for the dome light, they're a cause of drains. Aftermarket stereos, aftermarket alarms, those are kinds of things that we've seen drains on. Sliding doors for minivans, they tend to have drains or cause problems. So that gives you an idea of what could be causing a drain. So that's a parasitic drain test, and that's it for part 2 of battery testing.